Hello. Today we're going to talk about energy transformation in the spring mass system. So we have a spring here, we have a mass, and we have different positions. So this it's a nominal position. So there's no compression and no expansion. It's also called equilibrium position. This is in the maximum compression position. So this spring is being compressed to the left. So displacement from the reference here, this is the reference. It's going to the left. So right here, the displacement is going to the left. In this position, this is expansion, maximum expansion. So then this spring, it's being stretched to the right. So right now, compared to the nominal position, the displacement is maximum to the right. Okay? Now we want to look at the different energy. So different energy here, the position, potential energy, because there's no displacement. Displacement is equal to 0. So the potential energy is equal to 0. And in this position, if we started from, let's say, from the maximum compression, or if we started from a maximum expansion, when it comes to the equilibrium position, the velocity will be the fastest. So at this position, the kinetic energy will also be the maximum. Now, at the maximum compression position, the block, this M, will come to a stop. So the KE is equal to 0. The potential energy, on the other hand, is going to be maximum. So that's going to be 1/2 kx squared, and x is the displacement. And since the displacement is maximum, so is the potential energy also maximum. Now, when we come to the maximum expansion position, this block also comes to a stop. And now this spring has been stretched to the maximum displacement. And so your potential energy will also be a maximum again. Now let's take a look at the spring force. For the spring force, when your delta x is 0, or your x is 0, then according to Hooke's law, F is equal to kx. So your F spring, right? So spring force will be 0. Now, when you're looking at this position, the spring will be pushing this mass to the right, and the displacement is maximum. So this spring force will be at the maximum magnitude, and it will be going to the right. Now, when we come to this position, now the spring will be acting on the block to the left. So M is what we're looking at. So this spring force that's acting on this mass, this block, will be going to the left, and it's a maximum value also. All right, so we're gonna stop here, and we're gonna continue later. We're gonna continue. So this system is a spring mass system. So we have a spring, we have a mass, and it's also called a simple harmonic motion. So it's shorted as SHM. Now, conservation of mechanical energy is valid, so you can use it if the friction here is equal to 0. So in this case, when the conservation of mechanical energy is true, then the energy will only change from, say, kinetic energy to potential energy, or potential energy to kinetic, kinetic energy, potential energy and kinetic energy can transfer from each other. So in this case, the kinetic energy is maximum. So later, it comes to this state, then all the kinetic energy has been transferred to the potential energy. Also, from here to here, your potential energy has been transferred. All the potential energy coming back to here will be transferred back to the kinetic energy. Okay. So if you're in a random position like this, your displacement is not maximum, is not zero. So your magnitude of your displacement is larger than zero, but less than maximum displacement. Assume that's a positive number. And the magnitude of the velocity also is true, that it's larger than zero and less than maximum of velocity. Also, we assume this is a positive number, so we're looking at the magnitude here. So in this case, the mechanical energy in this particular situation is not just potential energy, it's not just kinetic energy. It's a sum of the two, which is 1/2 kx squared plus 1/2 mv squared, okay? So we also use the terminology of mechanical energy in the SHM. So that will be equal to the maximum potential energy. So when all the energy is stored inside the spring, or that also called maximum kinetic energy. And that's when all the energy is stored in the block M, right? And this is just the definition of spring potential energy, okay? And this is reviewing the Hooke's law that the spring force is equal to K times the displacement, all right? So that's all we have for today, and we'll see you